Okay, now that we've talked about how we're going to mark the fish, how do we use that to estimate the number of fish in our population? Well, this is a mark recapture study, very common in ecology. The basic idea is you capture a number of organisms, you mark them, you turn them loose, allow them to spread out, then you go take a second sample, and in that second sample you count the number of recaptures, so the number of organisms that have already been marked versus the number of unmarked. You compare that to how many that you have already marked, and you can estimate the population size. The details of how to do this are in your PowerPoint, and they're also in the homework. This is a technique that supposedly was developed by a scientist in France who wanted to count the number of homeless people in Paris a few hundred years ago. So he would surreptitiously put a chalk mark on the clothes of the homeless people. Then he could look at the number that he'd marked versus the number he hadn't marked, and he was estimating the number of homeless, and that's how this theory got developed. At any rate, we have two basic methods that we use, the Peterson method and the Schnabel method. They're pretty much the same thing. The idea is the same, is that you mark the fish, you turn them loose, you go back and you look at how many recaps you get. The difference is the Peterson, you only go one time. And from that one, you sample once, you mark, from that one resample, that's how you get your estimate. Whereas the Schnabel technique uses multiple mark and recapture samplings. And so you go out several times and you count the number of marked and unmarked each time. But the trick is every time that you take those unmarked and you also mark them. In that way, as over time the number of marked individuals gets higher and higher, and your estimate gets better and better. And you can put a 95% confidence interval around the estimate. So the Schnabel is a little bit better technique. Of course, it uses more effort. So the math for those is pretty straightforward. The Schnabel, it's a little difficult to figure out exactly what each variable means, but you've got your homework, and your PowerPoint explains it. Once you get a spreadsheet set up for these, they're very simple to do. So what I would like to quickly talk about are the assumptions for this type of technique. The first assumption is equal mortality and emigration between the marked and unmarked individuals. So mortality and emigration are kind of the same thing when you're talking about population size. They're organisms leaving the population. Either they're leaving, like forever, they're dead, or they're leaving. Now, if this occurs at an equal rate among the marked and the unmarked, then that's not going to influence your results. However, there are situations where this might not be true. For example, for fish, we have to handle them and mark them. And if we're not careful and we put a lot of stress on those fish, or if the mark gets infected, the marked could have higher mortality. So there's something to think about when you're designing your experiment. You have to take this into account. The next assumption is that equal probability of being captured between the marked and the unmarked. Now, this may or may not be true. Usually we assume that this is true. However, for example, a fish that's captured and handled and marked might be a lot more wary of boats for a while. And so they might be more likely to avoid a boat, and so the probability of capture in subsequent sampling trials might not be equal between the two. By the same way, you might get organisms that are more likely to be captured once they're marked. First off, you might be catching the slow and the stupid, and so you're just more likely to catch them multiple times. Another example is when I've known people that have sampled and done mark recapture on turtles, and so they use a baited net and capture turtles, and they've remarked to me about how we keep catching the same turtles over and over again. Well, you know, the turtle is basically getting a free meal. And so, yeah, I'm in this net for a while and I get handled. Well, what do I care? I'm a turtle. And so you might get some organisms that are trap happy. So you got to think about that. We're assuming that the probability of being captured is the same between marked and unmarked. Now, their assumption is you don't lose the mark. That seems fairly obvious, but you need to be aware of it. Some things that we do to check this is to double mark a fish, give them 2 marks. That way you can tell if they're losing one of the tags or one of the marks, or you mark the fish, tag the fish, and hold them for a while. That way you can get an estimate of tag loss, and then you can correct your numbers. Excuse me. Next assumption is that the marked organisms distribute themselves at random. And so if you give them some time, they will spread out. That's probably a fairly good assumption depending upon what scale you're talking about. If you catch a bunch of fish and you release them, they're probably going to spread about in that area, but they're going to be faithful to that area. A lot of fish don't roam very far, and so they're not going to spread themselves out throughout the entire population of the lake. So to compensate, you probably should sample in several different spots within the lake, and that way they're going to be roughly spread out throughout the entire lake. One thing you want to avoid is taking all your fish back to the boat ramp, do your marking, and then just releasing them all right there at the boat ramp. We know from tournament data that the fish don't really disperse a whole heck of a lot. So that might be a bad idea. Next assumption, all marks are recognized. This seems, again, like common sense. This comes into play especially with the fin clipping, where you need to be experienced enough to recognize the fin clip. The final assumption is no births or immigration. This is going to be the opposite of mortality and immigration. Births and immigration make the population get bigger. The problem is that fish that are born during the study or fish that immigrate during the study don't have an equal probability of being marked. So later on you might capture them, and if you're doing a multiple mark recapture, then you'll mark them, but they haven't always been there. And so they did not have a probability of being marked early on. Certainly the fish that are born are being born, with no marks, and the fish that come in have no marks. So this can really screw up your data. So you need to be aware of that. Now there are particular different ways that you can compensate for that. There are different models like the Jolly Sieber model, which is for an open population where you have fish leaving and coming. And there are sophisticated ways you can deal with that. You need to be aware of your population and what you're trying to do, and then determine which is going to be the best mathematical model for you. There's some software. I think there's something called Program Mark that the terrestrial ecologists use a lot for mark recapture. So if you're doing a mark recapture, think about your population, think about these assumptions, make sure that you have accounted for things like tag loss, and then this is a great way to get a good idea of the number of organisms that you have in your population. And that's it. Thanks a lot.